I'm often asked, what is engineering mechanics and how does it relate to other kinds of engineering that we might have heard about, such as mechanical and aerospace engineering? And so this video is going to try to answer that question. So first of all, what is mechanics? Mechanics is the study of mechanical interactions of a system with its environment. Or what I like to say is that it's forces and the motion or deformations that are caused. And I think it's illustrated well in this video with our former department chair, Jake Blanchard, riding with the Blue Angels. So there we'll see all the different types of mechanics come into play here. So first of all, we'll see smoke coming out the back of the airplane. We'll have thrust, so that produces a force on the airplane. And that's going to cause the airplane to start moving and to accelerate down the track. So force and acceleration, that's dynamics. That's EMA 202, a class you take your freshman or sophomore year. So that's rigid body dynamics. Now, once he gains enough speed, we'll see the pilot will turn some flaps on the airplane that'll divert the flow of fluid and exert a force on the plane that will push it up into the air. So again, that's rigid body dynamics, but also fluid mechanics. The fluid is the air, and the flow over the wings exerts a force and enables him to lift him up in the air. Now we're going to see the pilot do a bunch of maneuvers here, and I think his goal was to try to make Professor Blanchard pass out or throw up. But you'll see that Professor Blanchard made it through unscathed. But in some of these maneuvers, you'll also see quite a bit of deflection on the wings. We can only see their tail here, but you'll see those tail fins bend quite a bit. And so there's a force and there's a deformation or a bending of those wings. So that's also mechanics. That's solid mechanics. Here you can really see it, bending, right? That's solid mechanics or forces and deformation. And so how do we know that the wings can take that much bending, or how much bending they can take before they break and come off, right? That's strength of materials, solid mechanics. So that's a part of mechanics. And then in some of the extreme maneuvers, we also see that the forces cause kind of a chattering or a vibration of the wings. And so that would be structural dynamics and vibration. Which is also, again, forces and motion. So all of the different parts of mechanics are captured here. And so hopefully that makes a little more sense what mechanics is. There's a list of some of the topics, the classes. And mechanics has application to all kinds of things, to cars, to wind turbines, to satellites, space stations, airplanes. And so it's a part of many, many fields in engineering. And so it's the core science that you learn as a mechanical engineer is mechanics. Also maybe some manufacturing in a degree like that. In aerospace engineering, it's also the core science is mechanics. There you might focus a little more on the fluid flow, on aerodynamics, some of those aspects, but nevertheless it is mechanics at its core. Similarly, a lot of civil engineering, structures and loads on a structure and how much weight can this bridge take before it breaks, is also mechanics. So the engineering mechanics degree at UW Madison lets you focus on all of those things. One of the popular options in mechanics is the aerospace engineering option. So you can think of that as a minor in aerospace engineering. So again, a mechanics degree where you focus on the core science of mechanical and aerospace engineering. Basically, it chooses your electives for you. And you choose as electives rocket propulsion, satellite dynamics, aerodynamics, structural dynamics, things like that that have aerospace application. So you take an aerodynamics class. Actually, everyone in mechanics and aerospace option takes that. So you get to learn about flow over bodies and how we can model and understand that. This photo here is one of our PhD alumni who designed the landing system, this sky crane, or he led the team that designed the landing system for the Mars rover. This idea of a sky crane that hovers above the surface of Mars with cables to let the rover down gently onto the surface. So those are some of the types of applications you might see. Within mechanics, not everyone is doing aerospace engineering. There are lots of other focuses. Several of our faculty are experts in biomechanics and materials. So, for example, this video shows a white blood cell chasing a bacterium. And the white blood cell is deforming itself. It's stretching, contorting, changing its shape, pushing other things out of the way. Eventually it does capture that. So the forces and the motion that it is going through and the stresses it feels are all mechanics. That's also an important fact in understanding how cancer migrates through the body. If a tumor stays in one place, it's much less dangerous. But if the cancer cells are able to move and to migrate and to get into the bloodstream, they can infect the rest of the body and become much more serious. Mechanics is also at the core of understanding the strength of materials, from metals and common engineering materials even to natural materials. So this picture shows a micro SEM image showing the microstructure of mother of pearl. And it has this kind of brick and mortar structure. And it makes it very tough, so it can withstand a lot of impact. So understanding these things and the forces on a material and what makes a material strong, brittle, or flexible, or ductile, or strong or weak, or stiff or flexible, compliant, all of those things are mechanics. This last picture here shows a material designed by one of our faculty that has what's called a negative Poisson ratio. Most materials, when you pull on them, they get thinner in the middle. This material actually does the opposite. As you pull on it, it gets thicker. And that has all kinds of implications for forces and strength in mechanics. So I'm often asked, what's the difference between then mechanical engineering and engineering mechanics? They sound like almost the same thing, you just flip the letters around. And it's totally true that they are the same discipline, really. And so at the University of Wisconsin, there is a difference, and that's just in the way the two programs are set up. So the mechanics program has a stronger focus in kind of the core of mechanics, which requires a little more math, a little more solid mathematical foundation. And that allows us to go a little deeper, a little more rigorous into some of the core mechanics. It also allows you, if you do the aerospace engineering option, to be prepared for some interesting fun classes like structural dynamics or aerodynamics. So many of these pictures are showing you applications to some of those things. So that's the difference. What do you give up? You give up a little bit of the breadth of mechanical engineering, a little bit of the manufacturing classes. You can kind of lay the two curricula side by side and see what you get to take in addition and what you don't get to take. And so that's the difference. Both are outstanding majors. You really can't go wrong. The choice of mechanics over mechanical engineering would probably be driven by the desire to, to use a little more the math skills that you've had and go a little more in depth rather than in breadth. And or if you're interested in aerospace, to be able to tackle some of these specialty courses that allow you to learn about aerospace engineering and pursue work in aerospace engineering. All right, so I hope that helped to understand some of the differences between mechanics and mechanical engineering, and I hope you'll feel free to contact me or the other faculty if you have any questions. Thanks.